In a nuclear power station, moderator is used too. Okay, so moderator. Okay, you see, remember one thing: nuclear reactor, whatever parts are there, okay, whatever names are there, these are so important. Okay, so I will tell you what are the names they used to ask. Okay, so first one is the fuel rods. Fuel rods. What are the fuel rods we are using? What is the fuel we are using means uranium 235. There is nothing but natural uranium. Okay, this is natural uranium. Okay, so or we can use enriched uranium. Okay, so uranium 238. This is enriched uranium. Okay, so enriched uranium. Okay, so that is fuel rods. Okay, so next moderator. Okay, so I will tell you the reason also why we are using this. So moderators. Okay, next one is moderator. Okay, so why we are using moderator means in nuclear reactor, whenever you are sending this uranium material, okay, so our nuclear radioactive material, then fast moving neutron will collide with this one and more energy will be produced, heat energy will be produced. That heat energy we have to use to convert the water into steam. Understanding, right? So I will tell you, okay, so how we can convert. Okay, so later in the classes we can understand, but now, okay, so these are fast moving neutrons in every chain reaction. Okay, whenever high speed neutron collide with this uranium material, so 3 other neutrons also will be produced. 3 more neutrons will be produced. Those are very high speed neutrons. So what you have to do is, if you don't slow down these fast moving neutrons, these will immediately participate in the chain reaction again, and the chain reaction will be, so within very short time it will be improved like anything. Understanding, right? So that's why we have to slow down the fast moving neutrons. Okay, remember, you have to slow down. We are not killing the neutrons. Okay, we are just slowing down the fast moving neutrons. That's why we have to use this moderator. Okay, so remember, what is the use of moderator? We have to slow down the fast moving neutrons. That's why you have to use this moderator. Okay, so what is the moderator we can use? H2O. Okay, so water we can use normal water. Okay, otherwise D2O, deuterium water we can use, otherwise heavy water we can call. Okay, heavy water or normal water. Okay, so this is moderator. Use of moderator is nothing but to slow down the fast moving neutrons, not to kill, not to capture the neutrons. Okay, so this is moderator. And next one is nothing but reflector. Okay, so reflector. Okay, so once you see the nuclear reactor diagram, you will understand. Okay, see this fast moving neutrons, we are just slowing down, but if they are coming towards the uranium material, there is no problem. If that neutrons are going away from this one, that means escaping from this one means we are losing some of the neutrons, right? We have to use that neutrons definitely. Okay, that's why whenever one neutron is escaping from the uranium material, that has to reflect back. Understanding, right? Whenever these neutrons these are now slow moving neutrons only, but some neutrons may escape. That's why, so around this moderator we have to give the reflector. Understanding, right? Reflector must be there. Okay, because some of the neutrons may escape from the chamber. Okay, so that's why, so to reflect back this fast moving neutrons are slow moving. Okay, so whatever speed it is, whenever the neutrons are escaping, they should not escape outside. Okay, they have to come back to the uranium material only. That's why we have to use reflectors. Okay, so what is the reflector we are using means this is graphite. Okay, graphite reflector we are using. Okay, so now another one, so these graphite reflectors we are using, for example, if you want to stop the nuclear reaction, we have to kill the neutrons. There is no other way. Okay, we have to just kill the neutrons, otherwise we will capture the neutrons from inside. Understanding, right? What we will do, we will capture some of the neutrons from the inside to the outside. How we can capture that? We will send the rods inside. Okay, so from the top we will send the rods inside, and all the neutrons will capture to that rods. And so whenever neutrons will be capturing, there are no extra neutrons to collide with the uranium material. So nuclear chain reaction will slow down, or chain reaction will stop after some time. Understanding, right? So that is nothing but so we have to use some rods. So what are those rods called means control rods. Okay, so control rods. What are the control rods we are using means this is nothing but so boron or cadmium. Okay, so boron or cadmium we have to use. Okay, so those are control rods. See, each and everything is one of the previous bit. Whatever you are seeing, okay, so what is the moderator, what is the reflector, what are the control rods, what is the fuel rods, what is the fuel cells, like this they may ask. Okay, so already previously so many times they have asked these questions whatever I am giving. Okay, so anyway, in the classes you will understand like all the with the diagram. Okay, you will understand in detail, but this is enough. Okay, so this is a previous year questions, right? Okay, just understand this much only, we have, because we have very less time. Okay, so that's why. Okay, so control rods, boron or cadmium. So heat is produced inside the nuclear reactor. How to capture this heat? We have to send this heat into the heat exchanger. Who will carry this heat into the heat exchanger? Inside the heat exchanger, water is there. Hot water is present. That hot water need to convert into steam. Understanding, right? So what you will do is, one coolant you will send into the nuclear reactor, and that coolant will come as hot coolant. Understanding, right? So some cool coolant we will send like this, it will come as a hot coolant. That hot coolant will convert the hot water into steam. Understanding, right? So the operation of this thermal power plant and nuclear power plant is same only. Ultimately we have to produce the steam. Okay, so inside nuclear reactor we are having this. So inside nuclear reactor we are having this heat. We have to collect that heat using some coolant. Okay, so what is the coolant we are using? Okay, what is the coolant we are using means, we can use H2O, we can use D2O. So H2O means normal water only, D2O means heavy water, or we can use helium or hydrogen also we can use, H2. Okay, so these are all the coolants. Okay, so some of the potassium coolant, this is also there, but generally these are the majorly used ones. Okay, so these are the coolants. Okay, so the answer for this question, let's see. Okay, so whatever I have given here, everything is so important. Okay, so if you see the diagram once, you will understand even more points. Okay, so but whatever exam point of view they are giving, so these are only the ones. Okay, so in a nuclear power station, moderator is used to. Moderator, why we are using moderator? Absorb neutrons. Looks like similar one, right? It is not absorbing neutrons. Which is absorbing the neutrons? So the boron or cadmium rods are, which are called control rods, are capturing, control rods are absorbing the neutrons. Okay, so next one, reduce the speed of neutrons. So this is the correct one. Accelerate the speed of neutrons. Acceleration is not possible here, already they are high speed neutrons, we have to slow down. Okay, stop chain reactions. To stop chain reaction, what you have to do? Control rods. Okay, so we have to insert this control rods inside, so all the neutrons will capture to their control rods, so there are no neutrons which will participate in the chain reaction again. Okay, so answer for this question is B. So next one, if the star point of an alternator is grounded through an impedance Zn, the zero sequence net impedance is. Okay, so this is directly we have to answer this model of questions. What they have given is a star connected generator they have mentioned. Okay, so a star connected generator they have mentioned. If we have did the fault analysis already, okay, so then you will be answering this question without any analysis. Okay, so generally, so this is the ground, right? Okay, so ground, if any neutral ground is present, okay, they have given as impedance is Zn. Okay, so if any fault occurs on some of the lines like this, there will be positive sequence, negative sequence and zero sequence, all three will be present. Now what they are asking, the zero sequence net impedance is. Okay, so generally zero sequence impedance means only Z0. Understanding, right? But whenever it is star connected, so whenever it is fault occurring, then into this, okay, so 3 times of fault, 3 times of zero sequence current will fall. Okay, IA naught will be flowing into this one. So to represent this one as a circuit, what we will do is, current flowing into is IA naught, and we will take this one as 3Zn. Okay, so we will take complete Z equivalent, zero sequence Z equivalent is equals to Z0 plus 3Zn. Okay, zero sequence impedance of Z0 for the fault plus 3 times of Zn we will consider like this. Okay, so this is the answer for us. Okay, so once you understand about the fault analysis, okay, at that time you will see this model. Okay, so directly we have to answer. Okay, Z0 plus 3Zn, that's it. Should not waste more time on this model of questions, otherwise you will confuse. Okay. Next, in hydroelectric plants, operating cost is high, capital cost is high. Operating cost is high, capital cost is low. Operating cost is low, capital cost is low. Operating cost is low and capital cost is high. What is the input for this hydroelectric power station? What is the input? Input is nothing but the water. So water is costly or not costly? So we are getting this water from the rivers, okay? So we are not spending much amount on those things, okay? Only operationalities, okay? So to maintain that water, so we have to construct the dam. We have to make the reservoir area. We have to give all these at the beginning stage only. Understanding, right? So that means the initial cost, okay? So it is highest for this hydroelectric power station, okay? Initial cost means capital cost, okay? So we can call as capital cost. Okay, so capital cost, it is very high for the hydroelectric power station compared to any other power station, okay? Capital cost is high, okay? Capital cost is high. Capital cost is high. Okay, so among these two options, okay, so when only one is correct, okay? Operating cost, what is there in operating cost? Nothing more is required for this one, okay? Already input, if you take any of the power generating station, take the thermal. What is thermal? Thermal means what is the input required, okay? So coal is the main one required, okay? So for the nuclear power station, radioactive material required, okay? So uranium 235 or 238 is required. And if you take any of the other power stations, so definitely there will be some operational cost, there will be some input cost also. But for the hydroelectric power station, operating cost is very less because on the input we are not spending much, okay? So that's why operating cost is low and capital cost is high, okay? So this is the answer, okay? Next question, electrostatic precipitator is installed between electrostatic precipitator, okay? So if you remember directly, whenever you see this model of questions, okay, we have to just see, okay, where is it, okay, it is from the generation, transmission or distribution or from the analysis or the protection. Directly we have to see and understand, okay? So okay, this is electrostatic precipitator. Where we have studied? We have studied in thermal power station. Okay, so thermal power plant we have studied this one, okay? Why this electrostatic precipitator is required? Okay, from the boiler, okay, from the boiler there are flue gases coming like this. Okay, flue gases are coming, okay? So flue gases. Okay, so flue gases, what is this flue gases means? How these are coming means from the boiler, okay? So in the boiler what is happening? The coal is burnt, okay? Coal is burnt. Then whenever coal is burnt, there will be some ash content. So there are two types of ash. With more weight means that is called bottom ash, which is having very less weight means that is called fly ash. Understood, right? This fly ash, okay, is containing these flue gases, which are dangerous gases. These flue gases are very dangerous gases. That's why what we have to do, so we have to send these things into electrostatic precipitator. Okay, electrostatic precipitator we have to send. So in the electrostatic precipitator, what is happening means all these flue gases will be captured and only the smoke will go out. Understanding? Only the smoke will go out. That's what we are seeing from the chimney, okay? If you go beside, okay, so in the bus only or any of the train, if you go beside that beside this thermal power plant, so you will see the chimney, right? From the chimney, all the smoke will be coming out. So after the electrostatic precipitator only, you will be having the chimney like this, okay? So from the chimney, so there will be, so smoke will be going like this. Understanding, right? So what they are asking, electrostatic precipitator is installed between, okay, coal bunker and boiler. Okay, where is coal bunker? Before boiler, we have to use the coal bunker. We have to store the coal in this one. We have to crush the coal. After that only, powdered coal we have to send into this boiler. Understood, right? So that means between these two we are not giving, okay, boiler, furnace and chimney. So this is the boiler. This is the chimney. Between these two only we are giving this electrostatic precipitator. Understanding, right? See the other options, economizer and air heater. Okay, economizer will be here and air preheater will be here. So we are not giving anything in between these. Okay, so these flue gases will go through this economizer, air preheater, air preheater also, because they will improve the heat of those things. Okay, they will maintain, these flue gases are very hot gases, they will maintain the steam temperature, they will maintain the air temperature, they will maintain the, so whatever steam, not only steam, okay, so hot water temperature also. That's why we will use this as the feedback. Understanding, right? But these will not be entering into that. Okay, so but only just like if this is the pipe into this, okay, into this steam is going like this, means above this we will send the flue gases. So what will happen? Some of the heat will be transferred to this, because these flue gases are having a very high temperature. Okay, so that's why, so yes, electrostatic precipitator is required for any of the any of the thermal power station. Okay, see the another one, condenser and economizer. Where is condenser? After the turbine. Okay, so after the turbine we have to use the condenser to convert hot steam into hot water. Understanding, right? We cannot release that hot steam into the atmosphere, right? So what we have to do, we have to collect that hot steam, have to mix with cool water, and that hot water again we will use that hot water. Okay, so anyway, complete schematic you will understand. Okay, so in the subject only. So now answer for this question is boiler, furnace and chimney. Option B is correct answer for this one. Understanding, right? Boiler, furnace and chimney. Okay, next one. The stability of the power system is not affected by stability. They are asking, okay, how it is not affected. That means based on the options we have to check. Okay, what are the options are there from that? Okay, generator reactance, line losses, excitation of generator. Okay, so what is the power, electrical power output we are getting? That is nothing but EV by X into sine delta. Okay, so generally this is for a short transmission line only. So if you give the complete one, okay, so you will get the big equation. Okay, so you will study that equations in the static power flow equations in transmission and distribution. Okay, static power flow equations. Okay, so you will study these things. Okay, so later in the subject. Okay, so but this is just okay only for the short transmission line we have understood. Okay, that too lossless short transmission line, no resistance. Okay, so just only for the analysis. Okay, so generator reactance. Okay, for example, this is the generator having some input, mechanical input to this generator. Okay, so now after the generator there will be transmission line. Okay, after the transmission line there will be some load. Just a simple, okay, single line diagram, simple single line diagram. Okay, line is having certain reactance, I am calling X line, and the generator is also having some generator reactance, that is nothing but Xg. What is this X means? The complete one. Okay, X plus X line is nothing but is this X. Xg plus X line is nothing but this X. Understanding, right? For example, this X will increase means automatically electrical power output will decrease. What they are asking? Stability they are asking. Stability means we will check about this maximum only. Why to check entire electrical power output? We will check only this EV by X. Okay, so this is also called as P max. Okay, otherwise P equal to P, electrical power output equal to P max into sine delta. Okay, what is this P max? P max is nothing but EV by X. Now you see, okay, if generator reactance changes, automatically P max changes. P max is nothing but maximum power transfer capability through the transmission line. Okay, so similarly line reactance, if line reactance changes, automatically X changes, P max also changes. Excitation of generator. What is excitation of generator? E. Okay, so if E changes, automatically P max changes. What is the other option? Line losses. Okay, so in this one there is nothing like line losses we have represented. Understanding, right? So whenever line losses changes, stability will never change. Generator excitation changes, stability changes. Line reactance changes, definitely stability changes. All these things. Okay, so remember EV by X. Okay, so directly this one. On this also some of the questions they have asked previously. Understanding, right? Okay, next question. Which of the following power plants is the least reliable? Okay, so least reliable power plant they are asking. See the options. Okay, wind power station, tidal power plant, geothermal power plant, solar power plant. Okay, so compared to the reliability, okay, so in reliability point of view they are asking, so tidal power plant, solar power plant and geothermal power plant. Okay, so there is no much damage you will be getting directly, but when you see these wind power stations, okay, they are directly exposed to the atmosphere. So atmosphere temperatures or atmosphere any things, okay, they may affect these things, okay. So that's why reliability of these things, okay. So the which of the following is least reliable they are asking. So wind power station is least reliable, okay. Next one, graphite is used in nuclear power plant as a, see, direct question they are asking just some time before we have discussed it, right? Graphite we are using as a graphite, okay. So we are using as the reflector, okay. So reflector we are using, okay. So this is the answer. Generally they have given fuel, coolant, moderator, electrode, okay. So we are not directly this question, okay. So answer for this question is reflector. And generally we can use the graphite as the moderator also, okay. We can use as a moderator also, but we can't use as the fuel. Understanding, right? But generally, okay, in some textbooks, so they have mentioned like this, but answer for generally graphite where we are using means as a reflector, okay. Otherwise instead of boron or cadmium, okay, so boron or cadmium, the control rods what we can use, we cannot use this graphite because it will reflect definitely. So that's why directly we cannot use this graphite, okay. So answer for this question generally reflector is the answer for this, okay. So next one, the most appropriate operating speed in RPM of generation used in thermal, nuclear and hydropower plants would respectively is, okay. So what is the number of what is the speed they are asking, okay. Speed in RPM, okay. Operating speed in RPM they are asking, okay. So generally N is equals to 120 F by P, okay, 120 F by P. In all our these power stations, okay, thermal power station, nuclear power station or hydroelectric power station, we are using turbo alternators, okay. So turbo alternators. So generally turbo alternators means how many poles will be there means either 2 pole or 4 pole, okay. So 2 pole or 4 pole, okay. For example, if 2 poles are there, N equal to 120 into what is the frequency, we have 50 hertz of frequency only, so 120 F divided by P, P is equal to 2 means directly will get as, so 120 you will get 60 into 50 is nothing but 3000. This is the actual speed in turbo alternators, okay. So for 2 pole machine it is, okay, 2 pole generator it is 3000 RPM. Generally we are using this one in the hydroelectric power stations where we will be having more head and definitely we can achieve the speeds, okay. So that's why in turbo alternators 3000 RPM will be there, okay. So if you use the 4 pole, okay, so what you will get, okay, divided by 2 you will get, that means 1500 RPM you will get, okay. So this we can use in the thermal power station and nuclear power station, okay. So that means answer for this question is 1500 RPM and 3000 RPM, okay. Next one, the off diagonal elements Yij of a bus admittance matrix is equals to off diagonal, okay. So for example, this is the matrix Y bus matrix where we will be using this Y bus matrix in the Y bus analysis, okay. For the power system load flow we have to do some analysis, right, load flow studies analysis. That's why we will consider Z bus or Y bus, anything. So generally if it is 3 by 3, if I am considering YII, okay. So otherwise we can give as the bus names, okay. So we will use as Y11, Y12, Y13, okay. So Y21, Y22, Y23, Y31, Y32, Y33, okay. So what are the diagonal elements means, these are the diagonal elements, okay. So diagonal elements, what is the diagonal elements means, diagonal elements are directly admittance, okay. So sum of admittances, okay, sum of admittances at that node, okay. So at that bus we can write down, okay. Instead of node we will write down as bus means node only. So if you are writing Y11 means whatever admittances are connected at that bus, everything we will add and give this value, okay. So these are 7. Similarly, okay, if second element Y22 we are giving means whatever admittances are connected at that particular bus, everything we will add and give. And what are the off diagonal elements means, these are all nothing but off diagonal elements, okay. So what we are giving off diagonal elements means, for example, between 1 and 2 this is the first bus and this is second bus. We have a interconnection. Okay, we have a interconnection which is nothing but, okay, which is nothing but J 0.5 we have. Okay, so J 0.5. Generally J 0.5 means it is the impedance they will represent. Okay, impedance they will represent. What you have to do is you have to convert into admittance. Whenever it is admittance means you will get as minus, okay, so minus J2 you will get. Okay, so this is the admittance. Now what they have asked, what you will give this element, the off diagonal elements Yij, that means Y12 in this case, okay, of a bus admittance matrix is equals to, what you will give means whatever admittance is there, okay, so Y12 if you want to give, how you can give for this one means minus of minus J2 you will give, that means plus J2 only you will get, okay, so plus J2 you will get. Understanding, right? So minus of whatever admittance is present here, so that value you will give. Understanding, right? So between 1 and 2 means Y12 you will get this one, and similarly Y21 also you will get the same thing, because 1 to 2 or 2 to 1 it is the same thing only. Okay, see the option, same as the admittance of elements connected between buses 1 and 2. Buses 1 and 2, whatever admittance is there, directly are writing like this, we are not writing, okay, minus of that, minus of the admittance of the elements connected at buses I and J, that is the correct one. Okay, connected at they have given, okay, let's see, minus of the admittance of the element connected at buses I and J, okay, that is not the correct. So minus of the admittance of the element connected between buses I and J, between the buses I and J, okay, that means between these two. See the option how they have given. So directly you may consider this one, but option is C, between I and J, between 1 and 2, whatever is there, minus of that admittance we have to consider, not at buses. At buses means here some element will be there, okay, here some element will be there, not those admittances, okay. So these in between whatever is there, that admittance minus, okay, that we have to consider as off diagonal elements. Okay, next question. The number of iterations will be least in the following method to obtain load flow solution. Okay, so directly, so whenever you see least means, okay, fast it has to complete, right? Okay, we will answer fast decoupled. Wrong answer. Okay, that is wrong answer. So what is the answer for this means Newton-Raphson method. Okay, what is the specialty of Newton-Raphson means accuracy will be more. Okay, accuracy will be more, and that means error is less. Understanding, right? Error is less and number of iterations are less. Okay, so the number of iterations will be least in following method. Which method means number of iterations are less in Newton-Raphson method. Okay, number of iterations are less in Newton-Raphson method, but it will take more time. That means for less iterations only it is taking more time. Okay, so that means it is slow, very slow. Okay, but otherwise operating time, okay, or iteration time is more. Okay, so iteration time is more for this one. Okay, so compared to any other Newton-Raphson method, iteration time is more, but number of iterations are less. Okay, that is the answer. So next question. The value of transmission line impedance is 5 per unit with 10 MVA, 10 kV base values. Its impedance value in ohms is, impedance value they are asking. See this one, okay. So this is comes under Eastern Power Distribution Company Limited. So that means now, okay, so now it is in Andhra. So in Eastern Power they will be recruiting, okay. So that Eastern states, okay, Eastern districts, not states. So the value of transmission line impedance is 5 per unit. Transmission line impedance they have given. Z line in terms of per unit it is nothing but 5. Okay, with 10 MVA, 10 kV. 10 MVA, 10 kV. This is the base MVA, this is base kV, that's it. Okay, base values. It's impedance value in terms of ohms. Okay, impedance they are asking in terms of ohms. Understanding, right? So how we will calculate this one? First you need to calculate the base value. Z base. What is the Z base means? Z base you have to calculate generally. So if you have any doubt, okay, you can calculate like this. Generally, yes, we can give as apparent power is nothing but V square divided by Z. That's it, okay. Now you want Z, right? So V square divided by S. Only this formula is enough, okay. So V square, Z base you want. So V base square. See, from this only we can derive, okay. No need to remember this one also, okay. So directly, if you know this one, enough, okay. So V base divided by, so S base. Okay, otherwise kV base square divided by S base. What is the kV base? KV base is nothing but 10 kV. So you will get as 10 k square. Okay, so 10 k square means okay. So we will write down 10 k whole square. Okay, so divided by S base. What is S base? 10 m. Okay, so that means 10 square is 100. K square is m. Okay, so then in the denominator 10 m. M will be cancelled and you will get 10 ohms. Okay, so that has the Z base value. Z base value is 10 ohms. Now Z in ohms they have asked, we have to calculate. So generally how we can do the per unit value? Per unit value is nothing but actual value divided by base value. What is the per unit value? 5 they have given. What is the actual value? We have to calculate. Okay, so actual value in terms of ohms we have to calculate. In terms of ohms only, okay, in terms of ohms you have to calculate. And what is the base value? That is nothing but 10. Okay, so actual value is nothing but 10 into 5, that is nothing but 50 ohms. Okay, 50 ohms, not there in option, but this is the correct one. Okay, 50 ohms only the correct answer. Understanding, right? Nothing wrong in this one. The options only they have given wrong in the tier maybe. Okay, so next question. In single line to ground fault, okay, single line to ground fault in conventional phases, they are asking, okay. So the sequence components of currents are equal, positive and negative sequence components of currents are equal and zero equal. All sequence networks will be in parallel. Zero sequence component only will be present. See this, okay, so very important model this question are, okay, this model of questions. Even in the engineering services also they are asking this model of questions. Okay, so I will tell you, so all the faults, how the sequence networks are designed, okay, how the sequence networks are designed, okay, that means how we have to model these sequence networks. If you remember that, everything is simple. For example, it is LG fault means all connected in series. Remember that. Positive sequence, negative sequence, zero sequence. Just okay, so as a fast I am giving, okay, so positive sequence, negative sequence, zero sequence. How all these three are connected means they all connected in series. Okay, so they all connected in series and they're all connected series and they're all connected short circuited like this. Understanding, right? So that means this is the voltage VA1, this is the voltage VA, okay, so this is VA2, this is the voltage VA0. So what is the first thing means VA0, VA1 plus VA2 plus VA0 equal to 0. See the short circuit, okay, so that means this one, okay. And another one, current in this, all are connected in series, whatever current is going, same current only. That means IA1 is equals to IA2 is equals to IA0. This is for this, okay. So directly, no need to remember these, okay. Remember the network, how the sequence networks will be there whenever LG fault is occurring. Understanding, right? So that means you see what they are asking this one only, single line to ground fault. What are the conventional phases? Okay, so they are asking conventional phases means from first line to, okay, so from A line to ground fault occurred. How is the sequence network? How is the sequence currents and voltages? See the options. All sequence components of currents are equal. All sequence components are equal. Positive and negative sequence components of currents are equal and zero sequence is not equalities, okay. So generally option, this is wrong, okay. So first option only directly correct. All sequence networks will be in parallel. How these are? All are in series, okay. Zero sequence component only will be present. Not like that. All the three sequences are present for this, okay. This is for the LG fault. Okay, so remember all the other, okay, so for example, LL fault is there. LL fault means there is no ground involvement. So what will be present? Only positive sequence, only negative sequence, only these two will be present. So that means, and that two both are connected in parallel. This is VA1, this is VA2. Understanding, right? So what are the conditions means whatever current is going like this. So this is nothing but IA1 current, this is nothing but IA2 current, okay. If you observe something, VA1 is equals to VA2. No zero sequence, okay, for the LL fault, okay. And currents also you can observe. IA1 is coming in this direction, IA2 in this direction. IA1 is equals to minus IA2, otherwise IA1 plus IA2 is equals to 0. Understood? This is for the LL fault. For example, LLG fault. Okay, for LLG fault, all the three sequence networks are connected in parallel. All the three sequence networks are connected in parallel like this. Understanding, right? So remember, okay, so these are all. So VA1 equal to VA2 equal to VA0. Okay, and the currents also, if you add IA1 plus IA2 plus IA0 is equals to 0. Okay, those are the two conditions. Okay, so whenever triple L fault is there, okay, so triple L fault is there or triple LG fault, only positive sequence is present. Okay, negative sequence and zero sequence not present. Okay, so remember all these things, very important bits, all these. Okay, like this, so many other questions also there. Okay, so follow us, so you will be getting so many questions like this. Please prepare well. Okay, so these notifications in Telangana or Andhra Pradesh, okay, they will release the notification within 2 months only. They will conduct the exam. So whenever you see, okay, so then only how to prepare. Understanding, right? Whenever there are speculations like this, okay, before that only we have to be ready for these exams. Okay, so remember how to prepare before only. Okay, so otherwise we cannot achieve these things. Okay, there are so many aspirants who are ready to get this exam, okay, but don't have proper practice of the questions. Not only from power systems, okay, machines questions, machines, power systems, networks, measurements, and all our subjects, okay, electrical subjects, previous year questions only you just solve first. Okay, so then you go for other questions. First previous year questions, you will get all the 95% of the questions from the previous years only. Understanding, right? So later you will be getting into other questions. Okay, so please prepare well. All the best for everyone. Okay, thank you so much.